we're going to be starting in CAM mode. We're going to rough out this material here, and we can look at the material. I'm going to just show the material right now is this block of material, this thick rod. And you can see we got a little bit on the face of this. And anyway, so we're going to machine off, rough out this area here. And then we'll use a finish tool and come in and finish this off. We'll mill the hex, and then we'll spot drill the face. And then while we have the spot drill in handy, we'll spot drill the radial holes and then drill the face holes. And we won't do anything in AID for this demo. This is a demo of mill turn, and that should just about cover it. So we're going to do width step, and then if I look down on the list, I can see that this is a down left roughing tool, and I can go to my planner, my operations planner, and I can see that step 10 is the down left. I can double click this, and I can take a look at it. But then you also have your feeds and speeds and all that here. So that's the first tool we'll be working with. And we're going to want to, I'm going to get an ISO view here. So this is our standard view, ISO view. So now we're going to solid turn, rough out all this material here. So what we have to do, well, let's go to solid turn, and we'll do that with a linear. And you can see on the banner of the linear panel, it says a group of surfaces is required. And we're going to do this with step 10. And so what I'm going to do is I'm going to use my group arrow, and I'm going to start with this one. I happen to know that this is exactly in the middle, so I can use the adjacent picker here. Because it's part of a solid, it knows its adjacent neighbors. So if I pick that one, it picks the next adjacent ones. And then I go again, and then it picks the next adjacent ones, and the next one, and then the next one. So what we're going to do is machine the face of this all the way up to the outer ring here. So now for linear, it looks like, you know, the text has gone off the banner. We'll probably want to leave a finish amount. So I'm going to say 0.01 there and 0.005 here. So 5,000 is for the X because that's the radius. So in a diameter mode, that would be 10. And I don't know if 150 thousandths is going to be good on the path depth, but I'm going to hit go and see what it looks like. It might be okay. So I'm going to hit verify toolpath. I'll slow that down a little bit. And you can slow it down with the number key while it's running, like I'm doing now. And then if you notice, the tool went shooting off into space there. And the reason that is that on job info, either here or here, but I've got it here, on work setup, I've got specify home position turned on. So it's rapiding off to Z of 2 inches out in front of it, and then a diameter of 20 inches above it. So that's why the tool went zooming off out of in the upper right there. Okay, so good with that. Let me pick my finish. So there's the down left finish turn. Now with this same set of surfaces, we want to run a finish pass. So we can go back to solid turning and change to profile. It assumes, you know, it didn't fill in the finish allowance, assuming that it was going to be a finish pass. I did notice when we verified it, let me verify this again real quick, that we need to face this part of it off. So I'll go ahead and have our profile tool do that. So that means I'll click facing. And what this means is that with it off, it starts in the front and then works its way back. But if I turn facing on, it starts in the back and works its way to the front. So I want it to work its way all the way down to 0. So if I go to more, so I'm going to do an end extension, and I want it to be tangent. I happen to know that it's 0.875 from the edge of this to the center. I think that's all I need on that. So hit go. We'll look at it and verify. So looking good. Okay, so now let's go ahead and machine the hex. Now, the one thing it's going to need to do is it's going to need to rotate into position one of them, and I don't know what side it's going to go on right off the bat. So what I'm going to do is I'm going to grab my end mill, step 60, and then I'm going to create a point out in front. Right now, it says that it's at Z2D20, but before it rotates, it'll wrap it to 0 and then rotate. So what I want to do is to create a point, and it'll use this point to rotate around. So I'm going to say, and I don't know what side it's going to cut first. So I'm going to put this at Z2, which is where it's at in Z already. And I'm going to make the D at 0. So it puts a point here, and then this is where the tool can get rotated into position. So we're going to solid profile mill the outside of this. And in order to do that, we have to do it on the XY plane. So now we can see the Z is pointed out to here. And then we go to solid milling profile, but we want the active group to be this hex and the floor below it. So I'm going to do a select none. Then I'm going to use my group arrow and pick this bottom surface here, the floor. Then I'm going to use the adjacent again one time. That way it picks all the adjacent ones, but it also picks this radius. So I don't want the radius in the active group. So I'm going to control click it, and then it'll take it out. That all looks okay. I think I want to put some leads on it. So let's just put an arc lead on it. I'll just do the default, see what it looks like. And then hit go. So let's take a look at what that looks like. It looks okay. Okay, so now let's spot drill the face holes. Okay, so with step 70, and I see that I've got all this other toolpath that's kind of blocking the view a little bit. So I'm going to take and hide that toolpath, and I can do that by right-clicking it here, and then hide layer step. I'm also going to do these others, so I've hid the linear roughing. You can tell by the little caret. So I'm going to also hide this. So I'm going to show hide that, and then I'll hide the profile that we just milled. So now I got a clean slate to work with. We're inserting with our spot drill. We're on the XY plane, so we can go create from solid hole. We'll do the face holes first. Create from solid hole. We're going to pick any surface on the solid. I don't care about the hole size, but I do want to do just these holes. I don't know what size those holes are. The from solid is going to search for, if I tell it match diameter, no, it's going to search for every hole, including the big one. And I don't want to do that. I just want these 4 face holes here. So I'm going to say match diameter. I'm going to say by example. I'm going to go by example because I don't know what the diameter is. Then I'm going to pick the cylinder of that hole. So if I pick the cylinder, you can see in the dimmed field, it actually fills it out. It knows what the diameter is. I need it to search the entire solid. And then I also need it to match my Z-axis. If I don't have the match Z-axis on, it'll find the hole in the front and the hole in the back. Then I should get 4 holes. So if I look at 54 here, if I hit create all, I should get 58. And I do. The from solid hole, it knows the depth of the hole. So it's punching that spot drill all the way through the part. So we don't want that. So what I'm going to do is take and put that step in the active group. So right now I've got nothing in the active group. I'm going to use my step picker, as I call it. I'm going to pick step 70. And then I'll show that I have those 4 elements in the active group. And then I want to find out what the diameter is. I'm going to go ahead and do the chamfer with the spot drill. So if I right-click element data on this chamfer, I can see that the major diameter, here's the minor diameter, the major diameter is 353. So that's what I want to do the spot diameter as. So I got my four holes in the active group, and then I can go to Edit, Property Change, Holes and Points. And I'm going to put in the spot diameter, 0.353. Now, when you see these three fields together, you got to remember to press Enter, so it fills in the other two fields. And then when we accept, you'll see that it shortens it up. And if we verify, we'll see now we got a spot drill. So while we got the spot drill handy, let's go ahead and spot drill the outer holes. Surface on solid. This time the example will be that. This time we don't want it to match the z-axis. And again, we should get four holes, so we should jump up to 62. And then that works. Again, it's gonna make the hole too deep because it's assuming that we're wanting to use the depth of the hole. It knows the depth of the hole, but that's not what we want. Now I can do an F7 or element data on this, what looks like a cone, but you'll see that it's not, because the top of the cone, well, the top and bottom of the cone actually are curved, so it's just some spline surface that is connected from this cone to this cone. I happen to know that it's 0.278. So let's do that with these guys. This time we can't do a step picker. We have to do a new group. We have to individually pick the last four holes that we did. I'll pick that one, that one, that one, and that one. You'll see that the outer ring holes are in the active group. And then we can go Edit, Property Change, or we can use the icon on the toolbar here. Property Change, Holes and Points. And the spot diameter is 0.278. And remember to press Enter. And then hit Accept. Because this top chamfer is not a cone, when it found the hole down inside. So if we look to the side here, you'll see that it's actually down inside of the hole. So I think we're going to get a little clip when we do our verify. So we'll do our verify and just run it. You can see the little clip right there where the tool's coming in. So we have to, not only do we have to, and we get the errors. So what we have to do is move the hole, the level of those holes up to what it's supposed to be. And we can find that out by doing an element data on the outer ring. And then we can see that the radius is 2 inches. And then if we just look at one of the holes, I'll do an element data on one of these holes here. I can see that the level is 80 thousandths, or almost 90 thousandths down into the part. So what we need to do is now back to Property Change, Holes and Points, and change our level to 2. And if you watch, when you hit Accept, you'll see them move out a little bit. Not much. But if we verify now, we should be okay. Looks okay. Okay, so while we're here, let's go ahead and do our, it looks like a 1/4 inch hole. So let's find our 1/4 inch drill. So step 100. It looks like we just do it again. So we should jump this up to 66. So now we're at 66. Same thing though. It's finding the hole in the bottom. So then you can see that it's actually finding the bottom of the hole. So we have to put that step into the active group and move it out to 2 inches as well. So I'll use my step picker, step that, property change, holes and points, and change my level to 2. Okay, so let's do the face holes now. And that's, as I recall, the element data on this. I can see the diameter is 323. So I'm looking for a 323 drill, which I believe is that one, yeah. And then we're create from solid. This time we want to match the z-axis. Our cylinder will be that guy. That should do it. I think we're done. We're not doing the inside of this just a demo for mill turn. So if we verify this, there it is. And that's that.